Okay, so welcome to the first easy question for modeling using state space. This is a question. So first, we're going to try and identify the zero input response of this state space equation system. The system with this state space equation. Okay, so first let's remember that the system is represented as the state variable or the state vectors, which is essentially x1 dot, x2 dot, and so on is equal to the state space variable A, I mean the state matrix A multiplied by the state variables, which is x1, x2, x3, and there's no derivatives. It's essentially just these state variables plus the input matrix multiplied to the input variable, most commonly used as y. And then the uh, output matrix is, output vector, I mean, is provided as the output vector, I mean the output matrix added to, I multiplied to the state variables added to the feed forward matrix D multiplied to the input variable. Okay, so now that we know that, let's continue. So to solve for the zero input response of the system, we essentially just try to get the resolvent matrix of the input. So, I mean the input vectors, right? The input vector or the state vector, I mean. So okay, so so to do that, we need that is equal to the solvent matrix is R of Z, represented as R of Z, is equal to the transpose of S times the identity matrix of the state matrix, which is this, A, minus the state matrix itself, and we transpose that. So how do we do that? Let's take this. Let's solve for this, the Si minus A. So we know that this is a 2 by 2 matrix, and we all know that the identity matrix of a 2 by 2 matrix is essentially just 1, 0, and 0, 1. If we multiply that by S, it will become S, 0, 0, S. And we subtract this matrix with this. So it's negative 4, 0, 0, and negative 3. Okay, so now with that out of the way, we simply perform this. So we will end up with S plus 4, 0, and 0, and S plus 3. Now to transpose this, a 2 by 2 matrix can be transposed through the formula of the adjoint of this, of the matrix. Also, that's actually adjoint A over that A. And by doing so, let's continue. I think I can fit it here. Yeah, I can fit it here. So this, let's um we know that the determinant of this is simply this diagonal subtracted by this diagonal, but this diagonal is 0. So we know that the product of this diagonal is the determinant of the whole matrix. And to adjoint it, we just simply switch the position of this with the position of these two and the position of these two. So with that out of the way, this is going to be S plus 3, 0, 0, and S plus 4. And again, the product of these two would be the determinant, and I would divide the entire thing with the determinant. So it's going to be S plus 4 times S plus 3. But we know that if we multiply this essentially to every element of this matrix, this is simply going to be 0, and this is still going to be 0. But this is just simply going to cancel out and leaving this. And for this one, it's just going to cancel this out and leave this. So let's just straight up simplify it. It's going to be 1 over S plus 3 I mean, yeah, 1 over s plus 3. Oh, I forgot. We are supposed to switch the positions of this, right? So if we're going to switch its position, this is going to be s plus 3 over here. And this is going to be s plus 4 over here. Meaning, what will be left here is 1 over s plus 4. And 4, yeah. And this 0, 0. And this 1 over s plus 3. Now let's switch from the s domain to the t domain. And we're going to be left with, again, 1 over s plus 4 is simplified to uh, the inverse Laplace of 1 over s plus 4 would be e raised to negative 4. And the inverse Laplace of 1 over s plus 3 is e to negative 3, 0, and 0. Now with that out of the way, we now multiply this matrix, the state matrix, to the output matrix since we're already given uh, x of 0. So this is it. We have to multiply the 0 input matrix here, 4 and negative 4, leaving us with the answer 4 e negative 4 and negative 4 e negative 3. Negative 3. There we go. So the 0 input response of the given system will be this matrix. Let's box that with the blue line. There we go. So that is all for question number 1.